Hi everyone, this video is about system of linear equation, Gaussian elimination. Alright, so before we do anything else, before we do the reduction part, let's see how matrices are written. Okay, so we have got the system of linear equations to be ax plus by plus cz equals to d, ex plus fy plus gz equals to h, and mx plus ny plus pz equals to q, right? So if you were to gather all the coefficients like A, B, C, E, F, G, M, N, and P, you call this the coefficient matrix. If you were to also take the constant, okay, which will add one additional column to your coefficient matrix, that is when you call this matrix the augmented matrix. Okay, augmented simply means enlarged. Alright, so you have got an enlarged matrix. Yeah, so what then do you do to actually come to the row echelon form? You will have to do subtraction, addition, or multiples of rows accordingly in order to reduce into such a form. Right, so if you could reduce your augmented matrix into the form of this, where the second row first element and also the third row first and second element to be 0, that is when you say you have got the row echelon form. And if you were to use your CAS calculator, it is the REF command that you got to use. Okay, so when then do we use the RREF? RREF is to be used when you also have these three elements to be 0. Yeah, so but we hardly use RREF. Okay, so take note on that. Okay, so let's look at when do we get one solution, or we call it the unique solution, and when do we get infinite number of solutions, and when do we get no solutions. Alright, so based on the row echelon form that I've put over here, okay, if the two elements that you have to take note would be your U and your V. Yeah, so when your U isn't 0, that is when you have a unique solution. But the moment you have got your U to be 0, that is when you have to also check for your V to see whether or not you will have infinite number of solutions or no solutions, right? So if it is U equals to 0, but V not equals to 0, that is when you say there is no solution. And why is that? Is because with these U and V elements, you are actually forming U sec equals to V. Why is it sec? Because the first column gives the coefficients of your x, the second column gives the coefficient of your y, and the third column gives the coefficient of your sec. Hence, your U is simply the coefficient of sec, so it is U sec equals to V. So if U is equals to 0 and V not equals to 0, that is when you will have your sec to be equivalent to V over 0, and this is invalid. Hence, there is no way you can get a solution for sec, and therefore you wouldn't be able to also get the solution for y and x, right? So when then do I have infinite number of solutions? When U and V are both 0. Yeah, why is that? Because it is U sec equals to V again. If V is also 0, you are going to have your sec to be any value at all to give 0 on both sides, hence infinite number of solutions, right? So let's look at one example. We have got x minus y plus 2z equals to 1, 2x minus 5y plus 5z equals to 9, and 3x plus 3y plus pz equals to q. And your job is to tell me what are the values of p and q should be in order to give me no solution, in order to give me infinite number of solution, or in order to give me unique solution, right? So I'll have to perform Gaussian elimination. So do we need to always go with the sequence of first equation, second equation, third equation? There is no need for that all the time. So how then do I decide on which one to be taken as my first equation or to be put as my first row? I usually go with the coefficient of 1 for my x component. So when you look at it, this x has got a coefficient of 1, this x has got a coefficient of 2, and that x has got a coefficient of 3, and hence I have put 1, negative 1, 2, and 1 to be the first row, 2, negative 5, 5, and 9 to be the second row, 3, 3, p, and q to be the third row. But do get in mind that these equations might not be in this sequence all the time. You can actually rearrange it. Alright, so how do I reduce? Okay, we usually keep the first row. Hence, I kept the first row. The second and the third row, I'll have to subtract or add with a multiple of the first row. So how do I decide on what multiple? It is a 2 here that I got to change into a 0, and it is a 1 there. So what should I do? I must be minusing a 2. Only then I can get a 0, isn't it? Hence, I've decided R2 minus 2 times of R1. Okay, so it's 2 minus 2 times of R1, which is a 2, I get 0. Negative 5 minus 2 times of R1, which is negative 5 plus 2, which will give me negative 3. And it is a 5 minus by 2 times of 2, which is 5 minus 4, which will give me a 1. And for this 9, it is 9 minus 2 times of 1, hence 7. Okay, and what about for my row 3? It is row 3 minus by 3 times of row 1, because it is 3 that I wanted to turn into 0. So I'm going to do like, the subtraction accordingly. And once I have gotten these two to be 0, the next thing to do is to turn this 6 into a 0 also. So what then should I do? Okay, I will now deal with the new second and the third row. Right, so what do I have to perform over here? It is, what operation do I have to perform over here? It is R3 plus 2 times of R2, because it is this 6 that I got to minus by a 6 in order to give me a 0. Hence, it is a 6 which is in my row 3 plus by a 2 times of negative 3, which will give me 0. Alright, then I'll arrive to my row echelon form. Yeah, but do note that you can actually use your CAS calculator to come to this form by using the REF command. And if you want it to be the RREF, where you will have all elements to be 0 except for the leading row, you will have to then use the RREF. Okay, and that is what we call reduced row echelon form. Okay, right? So when do I get no solutions? Okay, based on what I have given to you earlier, I'll get no solution when I have P minus 4 to be 0 and Q plus 11 to be not 0, you see. Hence, when P is equals to 4, Q not equals to negative 11, I'll get no solution. And when do I get infinite number of solutions? I'm going to have P minus 4 to be 0 and Q plus 11 to be 0. Hence, P must be 4 and Q must be negative 1 to give me infinite number of solutions. And what about unique solution? I only needed to have my P minus 4 to be non-zero to get a unique solution. Hence, P minus 4 cannot be 0 and P cannot be 4. Okay, so that is about system of linear equations.